All right, so in order to answer this question 14 here, we first have to look back at number 13 and try to figure out what the sequence is. 1, 1, 2, 3, 5, 8. And we've seen this thing before. This is a good old Fibonacci sequence. And then I think it even says something like that over there on number 14. Okay, and so the pattern here is to get each number, like this 8 comes from adding the 2 up before it. 3 plus 5 gives us that 8. So, to get the next one, I'm just going to add 5 plus 8 to get 13. And then 8 plus 13 gives me 21. 13 plus 21 gives me 34. Next one's going to be 55, 89, 144, and then I wanted 13 terms, so the next one's the 13th one, 233. Of course it keeps on going, but that's as far as we need to go. The toughest part of the stuff that comes after it is understanding what I'm talking about with the notation here. So f sub 1 just means it's the first term. You don't do anything with the 1, it's just going, hey, it's the first one. In other words, that is the number 1. Let's say if I said f sub 5, that's the 5th term. 1, 2, 3, 4, 5, it's the number 5. It's coincidence that it's also the subscript down here at the 5. Okay, so now what we're doing is we're looking at this ratio here, s sub n plus 1 over f sub n. It is, the nth term is on the bottom, and the term that comes right after it is on the top of that fraction. So just as an example, if I choose the top thing to be f sub 5, the bottom one is s sub 4, right? We're just writing fractions like that. So it is the second one over the first one, the third one over the second one, and so on, and we're trying to see if this makes some sort of pattern. Does it approach some sort of number? So we're going to need a calculator for this, which I don't have. Somebody hand me their calculator real quick. Thank you. Okay. So I'm going to write down what we would type in the calculator, and then we'll type it in. So the first one's going to be the second term over the first one, which is just 1 divided by 1. No calculator for that. That's 1. Okay. The next one is going to be 2 divided by 1, which is just 2. Okay. And then 3 over 2, which is 1.5. 5 over 3, 1.66666, whatever, repeating, right? All right. It looks like something might be happening here. Let's keep going here. 8 over 5, which I think is just 1.6. 1.6. And then 13 over 8, right? So 13 divided by 8, 1.625. Does it look like something's happening with the numbers so far? It looks like so far I've locked in on 1.6, and there's some other stuff that's going on here. The next one is going to be 21 over 13. I'm just going to round this off. Maybe I do 3 decimal places. So 1.615. And then the next one is 34 divided by 21. 1.619. So I was going to round it off. The next one is, say, 55 over 34. 55, 34. This is strange. 1.61. That would round to an 8, right? Okay. And then I have 89 over 55. 89 divided by 55. 1.618. And it would stay there. 1.618. Okay. And then one more we had Oh, I guess there's actually two more. Over 89. 144 divided by 89. That 9's telling that 7. You got to round up, so 1.618. And then one more. That's the 233 over the 144. 233 divided by 144. 1.618. Sure, the rest of the decimals and stuff keep changing down back here, but it looks like we've locked in on every single one of these at this point to 1.618, 1.618, 1.618. There's more decimals. It's an irrational number that we're trying to get closer and closer to, and it has a special name. It's called the golden ratio. And it has an exact form, just like pi is an irrational number. It has an exact form. We just write it as pi. So the golden ratio is 1 plus the square root of 5 over 2. So watch as I type that in parentheses, 1 plus the square root of 5, close those parentheses, divided by 2. And this is the number that we're essentially getting closer and closer to as we're taking ratios of Fibonacci numbers.